Good afternoon and welcome back to the workbench. So today I want to do something a little bit different to the usual thing, and this is a quick little modification to this little desk light ornament thing. It's one of these little light up sort of fibre optic style filament sort of thingies. Lights up blue, as you can see, and that's basically all it does. So in the kind of style of Big Clive, I guess, I'm going to modify it to change the colour, or in fact I'm going to modify it to change its own colour, several colours, by putting some colour changing LEDs in it. I've got some here off AliExpress, which I bought just the other day, well, 3 weeks ago or so, and they just turned up recently, so time to put them in. Anyway, this lamp isn't mine, this is from somewhere else, and a friend of mine commented on it and said it was a bit boring just looking at blue colour the whole time, and I kind of see the point. It isn't that interesting. It's just a little sort of thing, and it could be quite useful if it had different colours. So I thought, let's give that a go and change it there. So I'm putting one of these LEDs into this, swapping it out for the blue one that's in there, and we should get a sort of multicolour display that, well, not multicolour I guess, but a display that fades in and out between various different colours, because these are obviously RGB LEDs with a little inbuilt controller in them that's merged between different outputs. So yeah, that's the idea of that. So the only problem with these is there's absolutely no data sheet for them whatsoever, and the listing is just 20 LEDs, 10mm, colour changing, slow fade, that was it. You can get quick fade ones as well, or sort of quick flash ones really. I didn't think that was very good because it was a bit too fast, but the slow sort of fading ones are quite nice. If you really like quick flickering ones, you can definitely get those, but not personally what I think is necessarily appropriate for something like this, which is, I guess, designed to create some kind of relaxed ambience, mood, rather than some kind of hectic strobe light effect like a nightclub. Anyway, so yeah, but I have looked around on Google here and I found a sort of a data sheet for a similar LED. These are for 3 and 5mm size, but I mean they're practically the same thing, I guess. This is from SparkFun. They sell a similar LED, and we got typical sort of things here. So standard ratings that you'd expect. Says max 5 volts. For green and blue, and max 2.2 volts for red. Interesting. So forward current 20 milliamps for each colour, and then we've got a DC voltage. It says here operating voltage, minimum 2 volts, typical 4.5, maximum 5. The lamp has 3 AAA cells, so it's going to be 4.5 to 5 volts, depending on how fresh the batteries are. So drive current 50 milliamps, 220 milliamps, 225 milliwatts power dissipation at 4.5 volts. We've got a little IC here, so you can see there you've got the 3 LEDs and the IC here, and very simple sort of thing, all integrated. And we've even got a little logic diagram of the different drive to the different things. This obviously has this little pattern that it just cycles through and repeats, and does that. I assume this data sheet will be very similar to the one I've got here. All these sort of things are usually quite similar. It doesn't mention anything about needing a current limiting resistor, and obviously the application diagram here, it just says hook it straight up to a battery, which I find quite interesting. So, however, on this other website here, I don't know, PC Board Canada, never heard of them, but they turned up. You can buy, they look pretty much exactly the same, and they have some notes down here. They say power requirements, and of course they mention that if you want to run it above 4.5 volts, you need to add some resistors. Now that does make sense. Obviously in here it says maximum 5 volts, so 5 volt there as the maximum supply. So obviously they figure you can run it directly up to 5 volts just without a resistor or anything, but these guys say you should run at 5 volts, you need a resistor, and above you need various different values, obviously. So I guess I need to do some testing on these ones to find out whether or not they actually need a resistor, and then I'll know how to proceed. So let's do some experimenting with this thing and try and figure out what would be the best course of action of how to modify this. So we'll just look at the actual original lamp for a minute and see how that works. So the bottom got 3 screws. One is for the battery compartment itself, which just comes off relatively simply. Okay, so there we go, 3 AAA cells, all in series, so 4.5 volts nominally. And then we got 2 screws here that hold the actual base into this top part. So first, for a start, let's see what the actual voltage of these is. So we've actually got a fresh set of batteries, so let's put that to voltage DC, and this is our negative end, that's our positive. So if we go on here, we got 4.5 volts from the batteries, with it turned off. If I turn it on, that drops to 4.4. Not very much at all. So yep. I wonder if we can figure out the current draw of this thing. So what are they actually running this at? So this takes 80 milliamps. So this light must be either overdriven, or it must be quite a high power light. Interesting. Now these are probably about I don't know, 600 milliamps at most. So yeah, that's not really going to last very long, is it? Technically. So in fact, if this uses less power, that's probably a good thing. Anyway, actually I'll leave this on current. Let's see. So I'm just going to take this apart. Take the screws out of there. Let's see. We basically just have a little base with a little board, resistor, and the LED here. Just another 10mm blue LED. And the resistor is blue, grey, gold, so that is I think 68 ohms, which is actually what the recommended value is for this on a 5 volt supply, according to that random website. But yeah, who knows? Try and figure this out. So that goes to here, and this goes in there, and we turn that on. So we get 20 milliamps. It's running different colours. We've got green, there's less, 20 milliamps on red, 30 on green, actually 12 on blue, so it goes down quite a bit. Now it's ramping up here. We've got a couple of colours on at once, so 30 milliamps, that's probably 2, and then that goes up to 25, 26, 27, so we've got 30. Yeah, so if I put this like this, we can see the actual colour pattern on the table there. So with all the ones on, we get about 40. So just down to red, we just get 20. Goes to green, we get 15, 14. When it changes to blue, goes into about 12. When all of them come on, we've got red and green, it's about 30, which makes sense. Red, green and blue. Green and blue, you get 25. You got red and blue now, you got 30 there. Yeah, it goes to about 40 with all of them on, it seems, which is not a lot really. Kind of makes sense. I mean, if each one is rated for what it's rated at, 20 milliamps or less, then of course you're going to get 45 or so when they're all on. So it doesn't really look like this thing needs a resistor. I mean, yeah, the first datasheet I looked at says it can run up to 5 volts without, and there's no mention of resistor whatsoever, it just says max 5 volts. And it does say driver current 50 milliamps. So quite possibly that makes sense. I mean, this is running at 4.5. It's taking up to about 45 milliamps and the maximum sort of thing. So yeah, I don't really see that there'd be any point in leaving the resistor on there. I don't think it's necessary. I mean, this is obviously running, I would say, within specification just fine, and it's using about half as much power as this anyway, so well, only up to half as much. It's not getting hot or anything. Seems to be alright, so yeah, I don't know, I can't see that there's, I mean, if it can drop down to 14 when it's only on one colour, it obviously doesn't need a current limiting resistor, because technically you would want it to be maximum 20 per colour, I think. All you really need to worry about is the power dissipation of that chip. Going to be an issue in total with all three colours on, but you know, would you need to limit that to 20 milliamps? I can't see it really. I think it looks like it follows that datasheet that I was just looking at, and that the maximum current for the whole thing is 50 milliamps, and you've got 20 milliamps per colour, but it's actually less because some of them may different forward voltage drop than others. So I would say don't need to worry about the resistor whatsoever. I think all that will do will just make the thing dimmer, and we don't really want that, because that just is increases the chance that this thing won't light up very well. So in actual fact, let's see how well it does light up with this on here. This is not a perfect representation of it, but it does in fact seem to work quite well. Yeah, the colour comes out the end there. It's not as bright as with the previous one. Unfortunately, but I think running it at night would definitely look quite good. And this base part does light up very nicely, so that does add to the effect. So it's not a not a big deal, I expect. Right, so I'm just going to solder this in here. So that's seems to be simple enough. You just unscrew this. So we've got a tiny little PCB there. Just has that resistor and that LED on it, and that's pretty much what you'd expect, obviously. Just that and two wires. So I'll take that resistor out and just replace it with a piece of wire, I think. It would be nicer to get more high-powered LEDs, but I don't think that's possible. The only way to get this as a colour changing one with a higher power would probably be some different model of LED, or to design your own from scratch. And yeah, put your own 3 LEDs, but of course the problem with this is then the fibres would all be pointing at different LEDs, so different fibres would light up different colours, which may not be desirable. So I think you do need the single lens, so maybe a high power RGB module there, for example, or yeah, well, that would probably be the best idea, wouldn't it? Yeah, I think a little surface mount RGB LED, 3 pins, and then you've got well, three LEDs in it, and then you'd have to have a microcontroller, but you know, that would require making another board to put that on and everything. And I guess, you know, you could do that if you really wanted high power or custom features. Nothing wrong with that. I mean, you could totally do it. But for this particular thing, it makes more sense to do it this way. So what's that? That's positive. So we want to put it. Wait a moment. The lens of this is flat on both sides. I wonder if they're all like that. That's interesting. Yep. They've got a long flat side here and a short flat side there. How strange. Okay. Which way around was this again? Okay, so that's positive here. So positive is the larger flat side, the longer lead. Anyway, that makes sense. There we go. Oh, these are slots instead of holes. That makes it a little bit more confusing. Okay. This will require this to be soldered in here. And then to push this down, make sure it's flush and straight on the board there. I can't tell. These might be more of those weird aluminium style wires or whatever they are. I'm not sure. They seem a bit odd. Not very good to solder onto, but that's on there. Yeah, some of these really cheap LEDs don't seem to be copper wired. They seem to be something else, possibly aluminium or something. Where's the screws for that? There we go. Okay, but there we go. That's that done. So long as you're not pinching the wires, otherwise you could short something out or the thing won't go on straight. But that looks alright there. So the question is, where'd the other battery go? There it is. Okay, so this should work. It does. There we go. So that seems to work fine. That's very bright. Don't look directly into it. Let's see if the... Let's see what the current consumption is now. It should be exactly the same. Oh no. That's interesting. What do we got when all three colours come on? 50, 60, climbs up to 60. Interesting. 70, 80 even. Well, that's interesting. I guess that lower resistance to the batteries gives a higher current, which is not necessarily a good thing. So, I mean, does that light up nicely? That lights up pretty well. That's pretty bright, but I don't know if that's good for it to be that be running that high current. So yeah, that's probably not a good thing. I think I'll have to put that resistor back. Alright, so now I've put a 39 ohm resistor in here. That seems to be the most logical value. So for a... So yeah, we're getting 20 on both. For just green we're getting 18. For just blue we're getting 18. So yeah, this is with a 39 ohm resistor. The current dissipation, or current draw, it's not really going above 30, 35 or so. So that's quite good. So I think that's what I'll use use this 39 here. That should be just fine. Yeah. The original resistor isn't going to work because it's actually 6.8. Obviously, it's too low. So there we go. But 39 seems to work. At least for a voltage of 4.5 with 3 alkaline cells anyway. Yeah, let's just see what the maximum current is out of this at any given point. Yeah, with just the red we got about 22, which is alright, I guess. $18 for red and for green and blue. Get 30, under 30 for 2 of them. Question is, what do we get when they're all on at once? Looks like we're getting a maximum about 32 with all the colours on. Whereas before it was spiking up to like 80, 70, 80 or something. Which was probably too much. So yeah, it's peaking to 30, 31, 32 when all the colours are on and it's doing white. But other than that, it all, yeah, which is fine. And each separate colour by itself is about 20 milliamps. We got, 22 for red, 18 for blue and green. That's pretty good. The website says don't go above 25, so we've got 22 on the red. That's not bad. And it's not on full most of the time anyway, so yeah, I'd say that's alright. Looks good to me. So that's done. Let's put the thing back together. So there we go. It's all done. It's all back together again. Changes colour quite nicely, and it's fairly more interesting than it was before with just the single colour. Admittedly, the brightness is a little bit lower than previously, but you do get the colour changing effect, so I guess it's kind of a trade-off. Like I said, if you wanted a brighter thing than this, you'd probably have to go for a surface mount LED, RGB one, maybe like I don't know, 1 watt or something, if you can get those, and then I guess drive it with your own microcontroller and all that. But hey, that's a lot of complication just for something like this. Much easier, obviously, to just buy some of these LEDs and just swap it around. So you just need one of those and swap the resistor out for a 39 ohm one. Obviously 6.8 ohm is not good enough, it's too low. So yeah, sort of thing. It looks quite good. You can see the colour on the ends there. It still comes out quite nice. We're better at night, I guess, in general, but overall it's quite a good little modification. So yeah, it'd be interesting, I suppose. Another thing you could do would be to get maybe some 3mm or 5mm or maybe 3. Put a bunch of them in parallel facing different sections of this, so maybe different sections of this would be changing different colours at once, although that might sort of just all blend together and it might just mostly go white. I'm not sure. Something to experiment with, perhaps. But it would certainly be interesting to add like a little microcontroller and a separate LED, or 3 separate LEDs, and create a custom sort of thing. You could even make it programmable or something, or completely random. You could have some sort of random number generator, picked up by ambient noise on a input pin or something, just to see what goes on. Or even instead of electrical noise, you could even get one that has a microphone in it. You could add a microphone or something and have it change colour every time it hears a noise or something like that. So yeah, but anyway, quite nice, quite fancy little thing, quite neat. You can play with it for hours. Yeah, make a nice night light. Very nice. I guess the runtime of the thing will be increased as well now that the current is about half of what the original one was, so that's a bonus too, I guess. But yeah, that's about it. Not very hard to do, not very complicated, and quite fun. So there we go. If you got one of these or something like this, you want to change it yourself, it's not hard, it's not bad. It's just a pity they sell these kind of, you can't really buy just 5 of them or something, you have to buy at least 20. I haven't really seen any auctions for any of these sort of things that are smaller rather than, except the 3mm or 5mm ones, which won't really work in this because you need that wider lens to get the spread out to all the fibres. I mean, even then the ones around the edges are still a little bit dimmer than the ones in the centre, but most of them do light up pretty uniform, so it's not bad. Anyway, a bit of fun. Hopefully that's interesting. See you next time. And for some bonus footage. I don't know how this looks on the camera, but if I turn my lights off and reduce the brightness, so doing the auto exposure compensation, you get to see possibly a bit more of how it looks like in real life. Which is to say, it actually looks pretty nice. So this kind of thing would work best in a dim room or at night, I guess. But yeah, it still is pretty nice in general. Well, there you go. A slowly fading, colour changing fibre optic lamp thingy. What fun.